The US Department of Energy has put out one of the most interesting requests for information that I have seen in a very long time. And this could end up being one of the most comprehensive approaches to nuclear technology that we have ever seen. The Department of Energy is seeking hosts for Nuclear Lifecycle Innovation Campuses, which is an invitation for states to express their interest in hosting nuclear lifecycle campuses, which they say is a new effort to modernize the state's nuclear fuel cycle and strengthen America's leadership in nuclear energy. The idea being that this campus could host a wide range of nuclear fuel cycle as well as advanced reactor technology. And they're inviting individual states to come in with a proposed plan of how they could make that happen and what it would look like, and why their individual state is the best choice to do this. The proposed campuses would support things ranging from fuel fabrication, enrichment, and even reprocessing and disposal of waste. As we've seen recently, reprocessing is back on the table in the United States, with multiple companies taking a look at what reprocessing could look like and how it could be used to fuel advanced reactors. But perhaps the biggest news here is the nuclear waste. Rather than the federal government saying, this is where we're going to store waste, and you just have to take it, like Yucca Mountain, which resulted in an endless fight and years and decades of nothing actually happening, now states can come in and say, we would accept nuclear waste as part of this nuclear life cycle campus. So it's a big move towards consent-based siting. Secretary of Energy Chris Wright said, unleashing the next American nuclear renaissance will drive innovation, fuel economic growth, and create good-paying American jobs while delivering the affordable, reliable, secure energy America needs to power its future. But the big difference here is this time it's the federal government inviting individual states to apply and say, this is how we think nuclear could flourish within our own ecosystem and within our borders. And of course, there could be huge advantages to any state that does move forward. Politico, citing an unnamed source on January 20th, said that the administration tends to steer billions, if not hundreds of billions, in related nuclear infrastructure and supply chain development, from fuel production and research to reprocessing and advanced manufacturing as part of a broader push to build out a domestic nuclear fuel cycle. But the request for information actually goes beyond that. It includes things like advanced reactor placement and co-location of data centers and advanced manufacturing. I pulled up and read through the entire request for information so that you don't have to, but there are a number of key points in there that are very interesting. The first is the timeline. They want this online by 2027, which is aggressively fast for a project like this. If they're talking about multiple fuel fabrication, enrichment, waste disposal, new reactors, data centers, having even a portion of that online by 2027 is extremely aggressive. It's also interesting where the funding for this is going to come from. The DOE says it's prioritizing private and state capital and rely only on targeted, conditional, and time-bound federal support when required. This means that, at least at this point, the Department of Energy is not promising any money that would be made available for this. Instead, it's going to be up to the individual states and private companies to provide the money. And while right now this is just a request for information, so that means that there's no potential binding contract at play, we do get to see a bit of what the Department of Energy wants to see at each of these individual sites and what states could respond with. Nuclear fuel reprocessing or recycling, so reprocessing facilities that could recover uranium, plutonium, or other isotopes for reuse. And this could be used in metal fuel for fast reactors or mixed oxide MOX fuel in light water reactors, with expected infrastructure such as reprocessing plants, isotope separation systems, and fuel fabrication units. Right now in the US, there isn't any really large-scale reprocessing. Oklo has proposed a facility that would do reprocessing, so this could potentially be part of that. And for fuel fabrication for light water reactors, there really aren't a whole lot of facilities right now. Westinghouse has their facility in Columbia, South Carolina. Framatome has their facility in Richmond, Washington, and GE produces BWR fuel at their Wilmington facility. So if there's increased demand coming from new reactors that are coming online, then additional capacity would likely be needed because most of these existing facilities are at or near their full capacity already. Disposition of waste streams. This includes development and safe disposal for long-term management, interim storage, and permanent final disposition. This is looking for states to come in with a proposal to essentially replace Yucca Mountain for a high-level nuclear spent fuel storage facility. And again, this consent-based approach is a much better idea than the federal government forcing a location that not everybody's going to want. Here, we're asking states to say, yeah, we'll take the waste and we're going to store it here. Because we do know how to store nuclear waste safely for a very long period of time, it's going to create additional jobs. It does mean that technology is going to be there. And if it's part of the campus where additional reactors are going to be built, fuel reprocessing is going to go on, then it provides the needed input that would be used for those activities. Next, conversion for fresh and reprocessed materials. Conversion transforms yellowcake into uranium hexafluoride for enrichment. And this is one of the steps that's required if you're going to take natural uranium that you've mined out of the ground. It needs to be converted into a gas, and that's uranium hexafluoride. Then once it's converted into a gas, it can be spun around in the centrifuges for enrichment. Conversion capacity is something that's been sorely lacking and been a bottleneck in the United States for a long time now. ConverDyn does operate a facility in Metropolis, Illinois, but it has had a lot of operational issues and is not at full capacity. And again, if we're looking at expanding nuclear and quadrupling it by 2050 within the United States, we're certainly going to need a lot more domestic support for conversion that would then support enrichment and ultimately fuel fabrication. Next, uranium enrichment for fresh and reprocessed uranium. Right now, the U.S. doesn't even have sufficient uranium enrichment capacity to support the existing fleet. A lot of it has to be imported mostly from, originally from Russia and then more recently from Europe. But the existing facilities in the United States only can support about 1/3 of the capacity currently required. So additional enrichment facilities are certainly going to be needed. Next, deconversion. So after the fuel has been enriched and it's in the UF6 form, it needs to be deconverted back into UO2. Again, this is normally done at the fuel fabricator, but if it's all co-located at a single site, that certainly makes things easier. Data center construction, so if we want to have co-located data centers on the sites, along with advanced reactor deployment. Since the United States has a goal of achieving 400 gigawatts of nuclear capacity by 2050, this could be one of the locations where those advanced reactors could be placed, co-located with data centers or other high-energy applications where reliable nuclear type of power would be useful. Uranium mining and milling, this will probably be quite difficult in the United States. Most locations won't have access to uranium mining, and those that do, the U.S. just doesn't generally have a lot of uranium left that could be mined. Isotope production for medical industry and national security. Isotopes like molybdenum-99 or cobalt-60 are quite useful for medical applications or for industrial applications where you need certain ranges of gammas and certain levels of activities. So this is something that's already quite limited worldwide. There's only a few types of reactors. Normally research reactors, CANDU reactors can also produce some of these isotopes, but having a new source of these would certainly be helpful. Advanced manufacturing for things like reactor components and cooling systems. This is one of the big criticisms of this potential build-out in the United States if we're aiming to quadruple nuclear energy, is that a lot of these components would have to be ordered from overseas, from places like Japan or from Europe or from South Korea or even China, because the United States lacks the domestic capability of building certain heavy components, especially heavy forgings are quite difficult and expensive. And unless you have a guaranteed or a long-term set of contracts that you can see this demand coming in the future, it's very difficult to justify the investment in being able to make those kinds of components. So advanced manufacturing would certainly be welcome here if we're planning that kind of build out and to have those local suppliers available. Proliferation resistance through advanced safeguards. And of course, anytime you're going to do reprocessing or separation of material, especially with plutonium or highly enriched uranium, you're going to want to have special controls to make sure that that material is not able to be redirected into areas that you wouldn't want it to go. The military is one side, but the civilian side and making sure that material doesn't fall into the wrong hands is ultimately something that we want to control as part of proliferation. But what caught my eye here was that it includes a statement that says measures may include real-time monitoring, secure storage of products of fresh fuel, and compliance with IAEA standards. Now, this may seem like an innocuous statement, but the U.S. has typically not always been directly in line with following what IAEA says in terms of proliferation control and approaches to safety. There's been a number of meetings between the NRC, Department of Energy, and the IAEA on trying to harmonize those standards. But every time, if you look at what they're looking at, they often identify areas where there are large gaps in what the IAEA's approach is versus the Department of Energy and NRC's approach. So it will be interesting to see exactly what they mean by comply with IAEA standards, because right now there is not that level of harmonization between the existing United States regulations and the IAEA standards and approaches. And finally, the last point of workforce development, safety, and environmental stewardship. One of the big reasons that we would want to see this in action is workforce development. Because the United States has stagnated on nuclear energy for so long, it's been difficult to fill a lot of positions because so many people have retired, while so few people have entered the workforce. The nuclear industry currently employs around 80,000 workers, but a single innovation campus could dramatically increase this figure. And they're saying that an innovation campus could employ as many as 50,000 direct workers and might generate 100,000 to 150,000 indirect jobs. So Department of Energy is aiming at a massive expansion here of around 60% of the entire workforce in nuclear energy in the United States at potentially one of these single innovation campuses. So this is a potentially massive economic and employment opportunity for any state that manages to get this and get it moving. So which states might be good candidates for this nuclear innovation campus? This could be states like Tennessee, which has Oak Ridge and a number of facilities within that area, Idaho, which has Idaho National Laboratory, which is hosting a number of the advanced reactor prototypes that are going to be demonstrated, as well as the existing facilities that are there for fuel, and a long history of hosting these kind of innovative facilities. Another possibility could be places that already are dealing with waste. This could be places like South Carolina, that already has the Barnwell facility, or New Mexico, which has the Waste Isolation Pilot Program for storage of Department of Energy spent nuclear fuel. There could be even places like California expressing interest, since there's a large number of tech companies and a lot of talent in those areas that people would be willing to participate in this. California Representative Mike Levin of the 48th District of California, which includes San Onofre, says the Department of Energy is taking meaningful, long overdue steps towards spent nuclear fuel by inviting states to weigh in on hosting the Nuclear Lifecycle Innovation Campus. While experts have conveyed skepticism that reprocessing is the right answer for shutdown plants storing nuclear waste in canisters like songs, I am glad to see that the innovation campuses also include waste storage and disposal and recognize state interest in reprocessing and other aspects of the fuel cycle. So at this point, it really is quite wide open on all the locations that could respond and could be good candidates for this. So what should we watch for next? Well, the first indication that we'll have is which states respond to the RFI and which governors express an interest in these facilities. Department of Energy does say it will prioritize states that can accelerate the timeline and get the campus up and running first. And while the RFI does talk about a single campus, it's not unreasonable to think that we could see multiple sites come up out of this. We could see one site specializing in nuclear waste and fuel reprocessing, and another specialize in heavy manufacturing and AI data centers. It all depends on what the individual states are best suited for and what they propose. And lastly, we would want to see what the private sector does. The majority of the funding for this is supposed to come from the private sector with limited involvement from the federal government directly. So if we see large vendors like Westinghouse, Framatome, GE, or some of the startup companies come in and say, yes, this is something we want to participate in and support, then we might start to see some preferences about locations and the types of technology and facilities that could be implemented. But now it's just a request for information to the Department of Energy, and responses are due on the 1st of April 2026, so we should know pretty quickly how many states are interested and where things might be headed.